and we actually know it's an amazing biodiverse place, and that insects are the cornerstone of those ecosystems.
Millions of frozen bees were dropped into the boiling sands of the Sahara Desert. It sounds like a mistake, but this was a calculated gamble to change the planet. Scientists believe these tiny insects could turn the endless dunes green again. They packed them in crates, lowered their body temperatures, and released them into one of the most hostile environments on Earth. But just 1 year later, the results left experts terrified. The bees did not just survive, they triggered a chain reaction that no one saw coming. And what they found buried in the data changes everything we know about our world. Sahara 0 Hour. In the middle of the Sahara, where the air shimmers with heat, dozens of crates are cracked open. Out of them burst bees, thousands, millions of them, rising right above the sand where temperatures sit close to 122 degrees Fahrenheit. People in white protective suits step back, and the swarm disappears into the haze. At first glance, it is total madness. Releasing bees in the hottest desert on the planet seems like a death sentence. But in 2023, a group of researchers decided to test whether it is possible to bring life back to the Sahara with the help of insects. For this experiment, bee queens were caught in Europe, kept in refrigerators to slow down their metabolism, and then transported across the sea and through the sands to the heart of the desert. All of this was for one goal: to make the lifeless land green again, to give plants a chance to restore the soil, and maybe one day turn these dunes into meadows and fields. But here is the catch: the Sahara does not welcome outsiders. From the first moment, it was obvious this experiment might not go the way they hoped. What happens when bees appear somewhere? Everything changes. Not gradually, but literally from the first days. Bees are the engine of the planet. Without them, half of the food we are used to simply would not exist. Almost a third of all crops in the United States depend on honeybees. We are talking about everything from apples and almonds to melons, lettuce, and broccoli. They connect plants into a single living system. When bees disappear, the chain falls apart and there is no way to replace it. Without pollination, plants cannot reproduce. Without plants, herbivores vanish. Without herbivores, predators go away. Step by step, nature crumbles. But this balance works both ways. When bees return to places where they had been gone, everything comes back to life. Flowers bloom again, seeds spread farther, and new forms of life gather around them. That is exactly what the experiment in the Sahara was meant for: to make the chain reaction of life begin again where there has only been sand for thousands of years. To make the desert itself disappear. It is hard to think of the desert as an enemy until you look at a map. The Sahara is not just sand, it is a giant that has already swallowed half a continent. The largest hot desert on Earth keeps growing, claiming new land from people every year. Its body stretches from the Atlantic to the Red Sea across 11 countries. In Algeria, it covers 80% of the land. In Libya, almost 95%. Even in Egypt, 2/3 of the country are already under sand. Satellite images show it clearly. The Sahara is not standing still. It is moving. But people still keep trying to fight back. Egypt, for example, grows crops right among the dunes. These are green circles in the middle of nowhere, like an attempt to prove that the Sahara can be fooled. But the desert does not retreat easily. Over the past few decades, it has grown by about 10% and keeps creeping forward, swallowing pastures and towns. So the idea of bringing life back here looks not just desperate, it is insane. Releasing bees into a place where the air itself melts rubber seems impossible. Bees are insects that typically die at 104 degrees Fahrenheit. In the Sahara, the sand heats up to 158 degrees Fahrenheit. But people still decided to release bees into the desert. To give you an idea of how sensitive bees are, let us take another hot place, Nevada. There are over 1,000 bee species living there, but since the early 2000s, their numbers have been steadily dropping. Partly because in the southern part of the state, it gets so hot that hives literally melt. And bees are not stupid. They just fly off looking for better conditions. Speaking of melting, that is not a metaphor. A hive can actually start to move and drip when it overheats. Bees do love warmth, but everything has its limit. The perfect temperature inside the hive is about 95 degrees Fahrenheit. If it gets any hotter, that is game over. The larvae can stop developing and die. The colony weakens. Sometimes even the queen stops laying eggs until it cools down. Adult bees usually handle heat a bit better, but at extreme temperatures everything falls apart. Literally at 104 degrees Fahrenheit, the honeycomb starts softening and collapsing because they are made of beeswax. That wax is the foundation of the whole hive. It is used to build those hexagonal cells where they store honey, pollen, and raise their young. It gives the hive its house structure. But wax is a tricky material. It melts in heat like a candle because, well, candles are made of wax too. So if the temperature rises too high, everything the bees built for weeks or even years just melts away into a puddle. There is even a real-life example. In 2022, in a Moroccan village down in the southwest, spring came with silence instead of the usual buzzing. Huge bee colonies died from drought. For a village where beekeeping was the main source of income, it became an ecological and economic disaster. And Morocco, by the way, partly lies within the Sahara zone. The desert does not cover the whole country, of course, but it is nearby. And apparently, bees there are already in serious trouble. So, for now, all this does not sound too promising. It is like the bees do not stand much of a chance in such conditions. But shockingly, something in the desert shifted when those crates opened. Breeding a monster. Here is the twist. Bees actually know how to deal with heat better than we thought. They have their own perfectly effective cooling methods. Like I said, the ideal temperature inside a hive is around 95 degrees Fahrenheit. In winter, bees keep it warm by huddling tightly together, sealing up cracks, and just buzzing. Yes, the sounds we hear from outside actually help them generate heat. In summer, it is the other way around. To avoid overheating, worker bees fly back and forth all day long, creating airflow. And when it gets really hot outside, the foragers bring back not only nectar and pollen, but also water. It evaporates and cools the inside of the hive. Some bees even fan their wings like tiny ventilators to keep the air moving. That is why beekeepers usually do not worry about their colonies unless the temperature climbs above 100 degrees Fahrenheit. That is already pretty hot. But most of the time, the bees manage just fine, blowing the hot air out of their hives. Real problems start only when the heat lasts too long, and that is exactly what happens in the Sahara all the time. Still, there is a way out. You could release not regular bees there, but local ones, those that already know how to live in the heat. And such bees do exist. For example, the East African lowland honeybee. It is a subspecies of the common honeybee and looks almost the same, just a bit smaller. Its upper body is covered with soft fuzz and its abdomen has black stripes. Basically, a bee like any other. It lives in the southern and eastern parts of Africa, already hot regions where other species would struggle. Over thousands of years, these bees have adapted to drought and heat. But that is not the only change. They have also become more aggressive. Naturally, they are not angry just for the sake of it. It is about survival. In Africa, natural selection works like this. Only colonies that can defend their stores and their hives survive. They chase away predators, fight competitors for food, and as a result, pass on their genes. The calmer, less active colonies simply vanished over time. There is another interesting option, the Arabian or Nubian honeybee. It lives just south of the Sahara in Sudan, Somalia, and the southern part of the Arabian Peninsula. Basically right around the region where we want to run our experiment. These bees handle drought really well and can survive summer heat above 104 degrees Fahrenheit. In the same conditions, other subspecies lose entire colonies in just one season, while the Nubian honeybees keep living and working. So if there are any bees that can survive in the Sahara, it is them. Scientists even call their heat resistance one of a kind. First off, they are a bit smaller than regular honeybees. It might seem like a small thing, but that is exactly what helps them deal with heat stress. Size really matters here because a smaller body means faster heat exchange. Such bees get rid of excess heat more easily and do not overheat. And when the hive gets crowded, there is actually more space between smaller bees, so the hive does not turn into an oven. Young bees inside do not get baked alive. That is pretty important. Secondly, they are lighter in color than other species. Their yellowish tone reflects some sunlight and their short hair helps them stay cool. Basically, they have a built-in sun protection system. On top of that, these bees live in smaller colonies, and if it gets too hot, they simply reduce their numbers to keep the hive from overheating. Smart, right? And that is not all. Nubian honeybees have genetic differences, special cells, and even slightly different behavior. In everyday life, they act differently, all for the sake of surviving the heat that kills other bees. In short, you cannot release ordinary bees into the Sahara. The climate would just wipe them out. But with these ones, it might actually work. At least they have a real shot. By the way, just 15 years ago, in the middle of the sun-scorched Sahara, they actually found bees. Real honeybees, alive, working, just lost among the sands. In the Kufra oasis, right in the northern part of the desert, scientists discovered bees that had been living there in isolation for about 10,000 years. Imagine that. The same colonies, generation after generation, surrounded by sand, cut off from the rest of the world. Technically, they are Apis mellifera, the same honeybee that pollinates apples, melons, nuts, and basically every third bite of food on the planet. But genetic analysis showed that the Kufra bees are noticeably different from all the others. It is like they have evolved on their own. According to researchers, these bees settled in Kufra around 5,000 to 10,000 years ago, right when the climate suddenly changed and the once green savanna turned into what we now call the desert. Today, all life in the oasis depends on underground water. Without it, nothing would survive. But before that climate shift, some 11,000 years ago, the Sahara looked completely different. There were lakes, rivers, meadows, forests. Africa was a green continent that later dried up and turned to sand. Today, we are talking about bees and the fact that there is still hope to bring them back. These hermit bees prove that life can hold on even in the very heart of the desert. And if they are released not into bare sand, but into places with at least a bit of vegetation where there is nectar to collect, the bees can survive. But survival brought a new problem that nobody in the white suits anticipated: the violent chain. If Africa manages to bring bee populations back, it will be a pretty big economic win. Pollination is not just about flowers and honey, it is a serious business. In the United States, for example, scientists estimate that wild bees contribute about $3 billion to agriculture every year. Add in the domesticated honeybees, and the total shoots up to $15 billion. And as I mentioned before, without these insects, half the fruits and vegetables we eat simply would not exist. Nothing can replace them. Not drones, not robots. In southwest China, where bees have almost disappeared because of habitat loss, all kinds of pesticides, and overly active honey harvesting, farmers had to take brushes in their hands. Yes, regular paintbrushes to manually pollinate apple and pear blossoms, transferring pollen from one flower to another. So, if the Sahara experiment works, it avoids this nightmare. But here is the catch. There is a place where bees in the desert do not just survive, they actually make a difference. It is Israel. Down south in the Arava Desert, life is buzzing, all thanks to honeybees. Local farmers have learned to grow bee colonies right among the sands, and the results are impressive. On the Porat farm in the Aydin settlement, bees are downright thriving. I mean, all around is scorched land, almost like a lunar landscape. And then suddenly there is the hum of hives and fields full of blooming plants. Arava Desert, which is part of the Negev, has unexpectedly turned out to be a perfect place for beekeeping. The air here is clean with almost no industrial pollution, which means the bees get sick far less often. Fewer infections, fewer pests, and healthy colonies produce steady honey and help pollinate the crops. The local farmers literally rely on bees. They rent hives from beekeepers and place them right on their fields. As a result, harvests grow richer and fruits and vegetables become better in quality. And by the way, farms in the Arava now produce more than half of all agricultural products in Israel. If I were a bee, I would definitely add that to my resume. So the point is, even in a hot, dry environment, bees can not only survive, they can become key players in the economy. So theoretically, something similar could happen in Africa. So what other benefits can come from releasing bees? For example, a chance to save the entire global population of these insects. And they really do need saving. There is a parasite out there that kills hives from the inside. The problem has been around for a long time. All across the northern hemisphere, beekeepers are reporting massive losses of bee colonies. And this is no longer just sad statistics. It is a threat to food security. You know how the chain works. Fewer bees, less pollination, smaller harvests, less food. There are several reasons behind these mass bee deaths: diseases, parasites, habitat loss, poisoning. But among all the enemies of bees, there is one that stands out as especially dangerous: the varroa mite. Sounds like some supervillain from the 80s, but in reality it is a tiny external parasite that latches onto a bee and drinks its body fluids, weakening it. The varroa mite is a real nightmare for beekeepers. It causes more damage than all other bee diseases combined. The parasite originally came from Asia, where it lived on the Asian honeybee, and as often happens, they eventually reached a balance. Everything was more or less fine until the 1950s, when the mite jumped onto the European honeybee, the one that makes most of the world's honey. And that is when the real trouble began. Because European bees do not have those defense mechanisms. The mites breed right inside the cells, with worker and drone larvae eventually infecting the whole hive. But what do African bees have to do with this? Simple. They are not afraid of the mite. Bees in other parts of the world are much more vulnerable. East African lowland honeybees live by completely different rules. They practically do not suffer from the varroa mite and can easily survive without human help. Local beekeepers do not even consider the mite a threat. They rarely lose colonies because of it. These bees come with parasite protection built into their factory settings, and that is where it gets really interesting. If African bees are truly resistant, they could become a real salvation for bees all over the world. We could, for example, try breeding hybrids, a mix of African and European bees that would keep their resilience. However, messing with nature always has a price. If the introduced bees manage to take root in a new place, they could become not just pollinators, but also part of the food chain. For example, food for the honey badger. Despite its name, the honey badger does not live on honey alone. Its menu is quite something. Insects, frogs, turtles, lizards, rodents, snakes, birds, eggs. Sometimes it even eats plants, berries, roots, bulbs. Still, the name honey badger exists for a reason. The thing is, this animal hunts not for honey, but for bee larvae that live inside the comb. For this delicacy, honey badgers are ready to endure hundreds of stings. They break into the hive, tear it apart with their paws, and lick out everything they can find. And yes, the bees attack, but come on, it is a honey badger. It just does not care. Their thick skin is almost impossible to pierce. If you look at the map, you will see the honey badger lives across nearly all of Africa except for the north. And right there in the north stretches the Sahara, a massive barrier dividing the continent into two different climate zones. Because of the heat and lack of water, neither tropical animals nor Mediterranean species can cross it. Right now, the Sahara is uninhabitable for the honey badger. Too dry, too barren, and not even much to fight with. But what if we added bees? If they changed the landscape, vegetation would appear and people might start settling there. Gradually, the area would become more hospitable, and then maybe, just maybe, the honey badger could really expand its range. But do not think this is just a fun animal fact. Yes, the Sahara is hot and merciless, but even now it is full of snakes. From harmless racers to venomous vipers whose bites cause swelling, bleeding, and tissue death. Not always fatal, but without a hospital, you are in trouble. These reptiles know how to survive even where there is not a drop of water, simply getting moisture from their prey. And now imagine this. If the desert starts to come alive with plants, farms, and water, new species of snakes will move in from nearby regions where it used to be too crowded for them. Makes sense, right? And sooner or later, the farmers who dreamed of growing crops and living peacefully will find hundreds of hissing, venomous neighbors under their feet. And that is when it is honey badger time. Snakes make up almost a quarter of its diet. Every honey badger grows up with them, hunts them since childhood, and over the years builds resistance to venom. For most predators, a viper's bite is a death sentence, but for the honey badger, it is just dinner with a spicy aftertaste. So bees solve two problems at once. They do not just change the landscape, making it greener, but they also attract a predator that can keep the number of venomous snakes in check. It all seemed perfect until the scientists looked at the satellite data from the Amazon. The ocean's end. So we release bees into the Sahara. Can it change, turn green, become an oasis? Well, actually no. And get this, we probably don't want it to. You cannot expect a single bee colony to just turn a barren desert into lush land. That is not how it works. For plants to even grow, they need water, seeds, and proper soil. Bees are pollinators, not gardeners. They help plants reproduce, but they do not create water out of thin air. Yes, in theory, if there were already some plants around, bees could speed up their spread, pollinate flowers, boost yields. But in practice, it all comes down to climate. There is little water in the desert, both above and below ground. Rainfall is almost non-existent and underground sources are scarce. And if greenery suddenly increases, competition begins. Every new plant will pull moisture from the same meager supply. In the end, some seedlings just will not survive. So, the bees' work won't give us the miracle we imagine. And honestly, wiping out the desert is not a good idea anyway. Strange as it may sound, it serves an important purpose. The Sahara is the main supplier of dust on the planet. And yes, that actually matters. Every year it releases between 400 and 700 million tons of dust into the atmosphere, which powerful winds then lift and scatter for thousands of miles. You think dust is a bad thing? Maybe if you live in a city hit by Saharan winds, but in fact dust carries iron and other trace elements that are vital for the oceans. Marine bacteria and phytoplankton use that iron to grow, and plankton is the foundation of all marine life. Without it, there would be no fish, no whales, no normal life in the ocean at all. So, Saharan dust drifts across the Atlantic, some of it settling over the ocean in the Mediterranean Sea. The rest gets carried even farther to the Amazon, Scandinavia, Japan. Yes, Saharan dust actually reaches that far, and in the Amazon basin it does some crucial work. It just so happens that the soil in the Amazon Valley is poor in phosphorus, an element plants cannot grow without. And Saharan dust makes up for that shortage, delivering nutrients, a natural fertilizer of sorts. Without it, the rainforest would not be as lush and alive as it is. Almost all the nutrients in this region are locked inside the plants. When leaves fall and start to rot, part of the nutrients go back into the soil and the trees immediately absorb them. The cycle is closed, but not perfect. On top of that, it rains a lot here and floods happen too, washing phosphorus out of the soil. The very phosphorus that is already in short supply. All of it drains into streams and rivers, carrying nutrients away, like constantly pulling the plug in a giant bathtub. And that is where Saharan dust comes in. It brings around 22,000 tons of phosphorus a year, almost as much as the rains wash away. The desert is basically providing the Amazon with humanitarian aid from a distance. But even without the Amazon, dust is an important part of the Earth's entire system. It affects the climate, the oceans, the plants. Turns out the desert that seems like a symbol of lifelessness actually supports life, just not on its own turf. For the countries that have the Sahara within their borders, it is a disaster. But for the rest of the world, it is a key part of the balance. Remove the desert, make it green with bees and plants, and everything would change. The Amazon would starve. The oceans would suffocate. It is far from certain those changes would be for the better. Closing the crate. And yes, scientists have not done any massive bee experiments in the Sahara on this scale yet. We were talking about a hypothetical scenario based on real biological data. But honestly, the idea tells us something profound. We look at the desert and see something broken that needs fixing. We see empty space and want to fill it. We see heat and want to cool it. But nature does not work in isolation. You pull a thread in Africa and a tree dies in South America. You release a bee in Algeria and a honey badger moves in, pushing a viper into a farmer's house. You stop the dust and you starve the ocean. The core finding that shocks experts whenever they run these models is simply this. The Earth is already engineered perfectly. The Sahara isn't a mistake. It is a massive, dusty, hot engine that keeps the rest of the world running. While the Nubian bees are tough warriors that can survive the heat, and while the honey badger is a beast that can survive the snakes, perhaps they are exactly where they need to be. The experiment of the mind teaches us that not every barren place needs to bloom. Sometimes the most lifeless places are the ones keeping the rest of us alive. We can try to play God with frozen bees and genetic modification, but the sand usually wins in the end. So would you trade a green Sahara for a dead Amazon? It is a terrifying trade-off, but one we might face if we keep meddling. What do you think? Drop a comment below, like and subscribe for more mysteries.